Hello everyone, in this video we are just going to test the SMS sending from our SIM900A module by programming the Arduino microcontroller by interfacing the same GSM module with the help of Arduino UNO microcontroller. Let's get started. So from the previous video, I hope we learned several basic AT commands testing in the GSM module and phone book AT commands testing in the GSM module, and also we tested the call commands, and then we built a simple application which is useful for dialing to a particular number and also which is useful for terminating the call that has been dialed from the GSM module. And now in this video we are just going to build a system which is useful for sending two different messages to a particular number using GSM SIM900A module or modem and Arduino UNO development board. So now let us try to fetch some basic AT commands required for initializing the GSM module and also for sending SMS from GSM module. So for initializing the GSM module, we are just going to use these two AT commands which we utilized in the building system of dialing a particular number. So these two are the AT commands required for initializing the GSM module. So we are just going to use the same AT command. And regarding the AT commands required for sending SMS, I hope we tested the SMS sending in the previous testing video, and also we tested the reception of SMS using the Docklight software and TTL module. And now we are just going to perform the same operation for sending an SMS from the GSM module, but this time we are just going to program the Arduino UNO development board for sending the AT command for sending SMS using the SIM900A GSM module. So these are all the basic AT commands. I hope you remember this. These are all the AT commands which is useful for sending SMS from the GSM module. So this is useful for configuring the text mode in SMS, and this one is useful for transferring or for sending the SMS from GSM module. So we are just going to utilize these two AT commands. This one is for mode configuration and this one is for sending the SMS. So let me just copy these two things. So those who have watched the previous video of testing the SMS sending and receiving in GSM module, I hope you remember the AT commands that we utilized. These three AT commands were the AT commands which we utilized for sending the SMS and also for receiving the SMS. I am just going to do the same process, but this time I am just going to perform it using the Arduino UNO development board. So I am just copying this. So the AT command that we sent is AT plus CMGF is equal to 1. And then we sent the \r and \n, which is the carriage return after this. So this AT command is useful for setting the text mode in SMS, and then we used this command for transferring or for sending the SMS from our GSM module. And now let us see how it is done. We did the same process in the Docklight. I hope you remember that. Now we are just going to do the same process via the Arduino UNO microcontroller. So what we want to send is, for sending an SMS, we just want to send this AT command is equal to, you just want to provide the phone number to which you just want to send the SMS, and then you just want to provide \r/n, that is the carriage return. Once it is done, it will be requesting you the message that you want to send. So I am just going to send two different messages. For now, let me just send the message to be button pressed, and after this message you just want to provide the command control plus Z. So that can be provided by providing the hexa value 0x1a, or you can provide the character 26. So this is meant for control plus Z in ASCII format. So after providing the message that you want to send in SMS, we just want to provide this character of 26, so that this message will be transmitted from the SIM card available in the GSM module to this number located right over here or provided right over here. So these are all the AT commands required for sending an SMS, and let us discuss about the system that we are going to build by discussing and describing the schematic part. You can see this is the schematic that we are going to build. This is the same schematic that we built for testing the call in GSM SIM900A module. I am just connecting the same TX pin of the GSM module to digital pin 10, RX pin of the GSM module to digital pin 11, and I will be configuring these two pins as software serial pins in Arduino UNO program. And I am just going to use the same two push buttons which is connected to digital pin 6 and 7. Now what I will do is I will be sending one message when I press on this button, and I will be sending another message when I press on this button. That is, let's take it to be whenever I press the button which is connected to digital pin 6, I will be sending the SMS button 1 pressed. And whenever I press the button which is connected to digital pin 7, I will be sending the SMS button 2 pressed to the same number. So let me just copy this. This is the first message and this one is the second message. So I will be sending the AT command of this one whenever the button which is connected to digital pin 6 is pressed, and I will be sending this AT command whenever the button which is connected to digital pin 7 is pressed. So I will be getting two different messages when you are pressing these two different buttons. So this is the logic. So this is the system that we are going to build, or this is a kind of application like SMS alert system. You can build the SMS alert system with the help of same example program that I am going to provide you in this video, and also with the help of same schematic that I am describing right over here. So other than that, you can clearly see the schematic. This is the Arduino UNO development board, and I will be powering up the Arduino UNO development board with the help of USB port, and GSM modem will be powered with 12V 1 amps adapter externally. And these two push buttons are configured in pull up format. So pull up means when the button is not pressed, I will be having high signal in the port, and when the button is pressed, I will be having low signal in the port pin. So this is the logic. Now let's open the Arduino IDE for programming this system right over here. So we will try to write the logic as per the system that I have explained right over here. That is, I will be sending two different messages whenever I press these two buttons. So this is the Arduino IDE, and we are just going to start writing the programming. So I hope you know the overview of this software, all the features available in this software. So as the first and foremost thing, I am just going to include the software serial header required, software serial.h. And as usual, I am just going to configure these two pins, that is the digital pin 10 and digital pin 11 as RX and TX of software serial communication. So I want 10 to be configured as RX and 11 to be configured as TX pin of software serial port. So for that, you just want to use the software serial, and here you just want to provide the object name my serial. Let's take it to be my serial, and here inside this you just want to pass two parameters. One is the TX pin, another one is the RX pin, that is RX comma TX. So here you just want to provide the pin number required to be configured as the RX pin. So in our case, I just require pin number 10 to be configured as RX and pin number 11 to be configured as TX. So this will be configuring the digital pin 10 as RX of the software serial port and digital pin 11 to be TX of the software serial port. And regarding this object of my serial, you can provide whatever name here you want, and you can use that object for configuring and also for writing and reading from this software serial port. Now as the initial step, I am just going to configure the baud rate for this software serial port. So as per the configurations that we did, the GSM module is having the baud rate of 9600. I hope you remember that. So I am just going to configure this serial port, that is the software serial port, which needs to be connected to GSM module at 9600 baud rate. So I am just using the same object and I'm going to call the function begin. And this begin function is useful for configuring the baud rate of the serial communication, and you can provide the baud rate right over here for configuring this serial port at 9600 baud rate. And as the next step, I just want to configure these two pins, that is the pin number 6 and 7, as digital input pins. So that can be done with the help of function called pin mode 6 input and pin mode 7 input. And that's it. That's all about the pin and port configurations that you want to do. And as the next step, we just want to send the initial commands that you want to pass to the GSM module. So here you can see these two are the initial commands that needs to be sent for initializing the GSM module, and this is also added to the initial command. As this is a text mode configuration in SMS, we are just going to pass these three commands, that is AT, ATE0 and AT plus CMGF for initializing the GSM module, and then we will be passing these two commands for sending an SMS. So here I am just going to initialize the GSM module. I am just going to use the same object of serial. And I am going to call the function write for writing the AT command. AT \r\n. So you can pass a string of data right over here to the write function for passing that data to the serial port. So whenever you use this object, it will be utilizing the digital pin 10 and 11 as RX and TX pins. So you can use this object everywhere in your program for sending data to this serial port and also for receiving data from this serial port. And after this, I'm just going to wait here for 500 milliseconds. And again, I'm just going to pass ATE0 for disabling the echoing of attention commands from the GSM module. So we successfully transmitted these two initialization commands, and now I'm just going to configure and send this AT command for configuring the SMS in text mode. My serial dot so this command AT plus CMGF is equal to 1 \r/n will be configuring a text mode in the SMS format of the SIM card. So this is a mandatory command when you are sending an SMS from the GSM module. Other than that, if you are making only call in your application, this is not required actually. And that's all about the GSM initialization commands that you want to pass. And after that, here I just want to check for two conditions, whether this button is pressed or this button is pressed. So let me just write the structure for the button checking. So when the button 6 is pressed, I'm just going to write an if condition for button 6, and in a similar fashion I'm just going to write the program for checking whether the button 7 is pressed. So when the button 6 is pressed, this condition will be true, and when the button 7 is pressed, this condition will be true, and the program lines written inside this condition will be executed. So this is the logic. When the button 6 is pressed, or the push button which is connected to digital pin 6 is pressed, this condition will be true, and the programming lines written inside this if condition will be executed. Similar fashion, the programming logic work for button 7 or the push button connected to digital pin 7. Now, as per our system logic, as I mentioned, whenever I press this button which is connected to digital pin 6, I just want to send the SMS of button 1 pressed, or I just want to pass all these AT commands. So let me just pass this AT command first. My serial dot write of So there is some problem you can clearly see, because the AT command itself is containing double quotes in it. So we just want to enclose double quotes for this mobile number, right? So for that, for adding the double quotes in your serial write function in the Arduino IDE, you just want to provide a backslash before this double quotes. Here also, wherever you are adding double quotes, you just want to provide the backslash in front of it. Now you can see it is clear. And after this, you just want to provide the message that you want to send, button 1 pressed. My serial dot write of button 1 pressed. And again, you just want to write control plus Z or character 26. That's it. And that's all about the characters that you want to send for sending the SMS of button 1 pressed. And before or in between each of the transmission, just give a delay of 200 milliseconds or 100 milliseconds as per the requirement you have. If you want a speeder process, you can neglect these delays. At least provide a 1 millisecond delay, which is better for several applications. And I am also providing the AT plus CMGF before this SMS sending process. Let the text mode be configured before each of the SMS sent. And now we are completed for the digital pin 6 process. You can clearly see whenever I press the digital pin 6, the SMS button 1 pressed will be sent. Let me just give a delay of debounce delay of 200. And whenever the button which is connected to digital pin 7 is pressed, I just want to send the message of button 2 pressed. I'm just copying all these things and I'm going to change this to be button 2 pressed. That's all about the logic that I want to write. You can clearly see the logic is built. This logic will be executed and the button 1 pressed will be sent as an SMS to this mobile number whenever I press the button which is connected to digital pin 6. And when I press the button which is connected to digital pin 7, this logic will be executed and these 80 commands will be sent and the SMS of button 2 pressed will be sent to this mobile number right over here. Now I am compiling the sketch. Sorry, something is wrong right over here. Sorry. This is not digital write. This is actually digital read. I just wrongly mentioned that to be digital write. A digital write is meant for writing to an output pin. Digital read is meant for reading the status of input pin. Sorry, I just forgot this thing. Now I am just compiling. You can see the compiling is done. Now I have already connected the Arduino UNO development board to the PC USB port. Now I am just going to write this program to the Arduino microcontroller. The program has been dumped to the Arduino microcontroller. Now let's try to build this circuit in the hardware and then we will try to visualize the output of the system physically in the hardware. Now you can see this is the Arduino UNO development board and this one is the SIM900A GSM module with the SIM card inserted in the SIM slot. So now I'm just going to make the connection between these two modules. So the terminals that we are going to utilize in this SIM900A module is this ground, TX and RX of UART communications. So I'm just going to connect 3 jumper wires over here. So regarding the ground of the SIM900A module, I'm just going to connect it to ground of this Arduino UNO, and TX of this UART line of the SIM900A module will be connected to RX of the Arduino UNO development board, and RX of the SIM900A module will be connected to TX of the Arduino UNO development board. So as per our software serial configuration, the RX pin is nothing but the digital pin 10 of Arduino UNO. So I'm just going to connect the TX of the SIM900A module to the digital pin 10 of Arduino UNO. And as per the software serial communication that we configured, the TX of the software serial port is digital pin 11. So I'm just going to connect the RX of the SIM900A module with the digital pin 11 of Arduino UNO, which is the TX of Arduino UNO serial port, which we are going to utilize. And regarding the ground terminal, I am just going to connect it to the ground of the Arduino UNO development board, and that's it. Now I am just going to power up this Arduino UNO development board with the help of this USB port available right over here, and I am going to power up this SIM900A module with power jack right over here with the help of 12 volt 1 amps adapter. Let's visualize the output in the hardware. You can clearly see this is the push button that I am going to use in the project, but the push button that you actually have seen in the schematic is having only 2 terminals, right? But this push button is having totally 4 terminals. The push button logic and all the functionalities of push button is same, but the only difference this push button has is it is having 4 terminals, namely. So these 2 terminals right over here are interconnected and it is internally sorted and it is available for connection in both the ends of the push button. And in a similar manner, these 2 terminals of the push button are internally sorted and it is available for connection in the both ends of the push button. So that is the difference. You can use any one of these 2 terminals. This is actually a separate terminal and this one is the other separate terminal of the push button. So we can use either side of this push button for connection in our circuit. So for that purpose it is physically available like this. So I'm just going to use this push button only in pull down logic. Here you can see I have already built the basic circuit in breadboard with the pull down resistors for these 2 push buttons, which needs to be connected to the digital pin 6 and 7 of Arduino UNO. So here you can see clearly I have utilized these 2 terminals of push button, and you can see one of the push button, that is this one. Let me just remove all this messing of wires so that you can clearly see what is the circuit built. Now you can see the blue wire right over here is the terminal which is going to the digital pins of Arduino UNO, and here I am having yellow wire which needs to be connected to digital pins of Arduino UNO, and this push button I am just going to connect it to digital pin 6, and this push button I am just going to connect it to digital pin 7 of Arduino UNO. So this blue wire will be going to digital pin 7 of Arduino UNO and this yellow wire will be going to digital pin 6 of Arduino UNO, and to the same 2 terminals which is connecting to the digital pins of Arduino UNO, I have connected the pull up resistors, that is 10 kilo ohms resistor is connected from that terminal to the VCC of the circuit. So this orange terminal right over here I am just going to connect it to 5 volt of Arduino UNO, and this gray terminal I am just going to connect it to ground of Arduino UNO. So this whole line right over here which is connected to gray wire is the ground rail, and this orange wire connected rail is the positive rail of the breadboard. And regarding the other 2 terminals, that is the white terminal in this push button and the brown terminal in this push button is connected to ground of the circuit. Since we are using the push buttons in pull up logic, I have connected the free end of the push buttons to ground of the circuit. So now what happens is, as per my explanation in the previous video, whenever I press the push button I will be receiving 0 volt signal in the digital pins of Arduino UNO, and when I release the push button I will be receiving 5 volt signal or high signal in the digital pins of the microcontroller. Let us just make the connection between these push buttons and the Arduino UNO development board. So here is the Arduino UNO development board. So as I mentioned, I am just building the circuit based on the schematic shown to you. So no worries, you can refer the schematic for the connections, or you can physically watch this video for connection. So as I mentioned, this gray wire is the ground rail. I'm just connecting it to ground of the Arduino UNO. You can clearly see, and this orange wire is the positive rail of the breadboard. So I'm just connecting this orange wire to the 5 volt of Arduino UNO. So you can clearly see I'm just making this rail, that is the gray wire rail, as ground of the circuit, and the orange rail as positive rail of the circuit. And regarding the ground connection of push buttons, I have already made it in the breadboard itself, and I'm just going to connect this push button, that is this push button yellow wire, to the digital pin 6 of Arduino UNO, and the second push button I'm just connecting it to digital pin 7 of Arduino UNO. That's it. You can clearly see I have connected yellow wire to digital pin 6 of Arduino UNO, and blue wire to digital pin 7 of Arduino UNO. And that's all about the connections. As we have already connected the GSM module to the Arduino UNO development board, let's power up this Arduino UNO using USB cable, and let's power up this GSM modem using this 12 volt 1 amps adapter, and let's visualize the output in the hardware. Now you can see I have already built the circuit that I have already shown you right before. So just now we did that, right? So this is the Arduino UNO development board, and this one is the SIM900A GSM module, and these two are the push buttons connected to digital pin 6 and 7 of Arduino UNO. And as per our logic, when I press on the push button which is connected to digital pin 6, the message of button 1 pressed will be sent to this mobile phone number, and when I press on the second push button, the same mobile will be receiving an SMS from this SIM card available over here in the SIM900 module, that is button 2 pressed. So when I press on this, I will receive the SMS button 1 pressed, and when I press on this push button, I will get the SMS button 2 pressed. So let us check whether the program is working fine. I'm just pressing the push button 1, which is connected to digital pin 6 of Arduino UNO. You can see the button 1 pressed message has been received. I'm just opening the message. I'm opening the inbox of the mobile phone. You can see I have received 2 messages because I have pressed this button 2 times, right? So I received button 1 pressed 2 times. Now when I press the push button 2, I must receive the SMS button 2 pressed. So let me just test that. I have pressed the push button 2, which is connected to digital pin 7 of Arduino UNO. You can see I received the SMS button 2 pressed. So in this manner, you can send SMS using SIM900A module using any microcontroller, but in our case, we have sent the message using Arduino UNO microcontroller. So this is the output which I got in the hardware. That's it. See you in the next video. Thanks for watching.